So again, this should be all review for you. We're just putting all the motion stuff together in one place. So if x of t is the position of a particle on the x-axis at time t, by the way, it could be on the line y equals 3. Okay, it could be on the y-axis. They're not always on the x-axis. The integral of the velocity, v of t dt, gives you x of t. Right? That makes sense. You know that the integral, the indefinite integral, gives you an antiderivative. Right? You'll have a constant of integration term c, but if you're given, and it's called an initial position even if it's not time equals 0, but if they give you a time and a position, you can figure out the value of c. So that you can pin it down to there's just one instead of a whole family of functions. Okay, we know that if we take the definite integral of v of t dt from a to b, we get x of b minus x of a. That's just displacement. What is the difference in its final position minus its initial position? Okay, you've done that a ton in physics. So if we know the position at time t equals a, we can find the position at time t equals b using this. Okay, so frequently they don't ask you for the displacement. They'll tell you at time x at t equals 3, x is equal to 17. And they give you the velocity function and ask you, what's the position at time t is equal to 12? And you can just substitute into this and find that then. Okay? All right. And then last but not least, quick review. If we take the integral from a to b of the absolute value of v of t dt, that gives you the total distance traveled. Right? The displacement is final position minus initial position, but it may have changed directions sometimes more than once. So if you're doing this by hand, and sometimes you will have to be able to do this by hand, first find all the times where the velocity is equal to 0. Then break the integral into several parts. So if, for example, we're doing the integral from a to b, and at time c and at time d, the velocity is 0, what we can do is take the absolute value that we get from this definite integral and then add it to the absolute value that we get from this definite integral and add it to the absolute value that we get from this definite integral. That will give you the total distance traveled. Now, I honestly don't do this a whole lot. I wasn't, when I learned this and then even taught it, what I would do is if the velocity was positive on this, I didn't bother putting the absolute values. And then if the velocity was negative from c to d, I would just put a minus sign here. It amounts to the same thing, right? So either is fine. And that's it. That's integrals with motion. So you can go and get started on your assignment.